Hello students, welcome to the session of panoramic physics. Students, today we will discuss the vector form of Biot Savarts Law. Biot Savarts Law किससे डील करता था? करंट एलिमेंट से. आप जानते हैं एक वायर, करंट कैरिंग वायर मैग्नेटिक फील्ड बनाती थी. ओस्टेड उससे पहले ही प्रूव कर चुका था. अगर एक छोटा सा करंट एलिमेंट उस वायर की एक छोटी सी लेंथ dl ले ले, अगर उस लेंथ एलिमेंट से इनफाइनाइटेसिमली स्मॉल, बहुत छोटा सा एलिमेंट है, ठीक है, can it produce a magnetic field? Yes, it can produce magnetic field, and that was studied exclusively by Biot and Savarts ने उसको स्टडी किया, and they gave a law, Biot Savarts law. इसकी स्केलर फॉर्म थी mu naught upon 4 pi ideal sin theta upon r square. Now let's see, यहाँ से अगर हमें mu naught निकालना है, it will be dv into r square 4 pi and ideal sin theta will be in denominator. Now what will happen? Here you can see we have to find its units. What is the unit of magnetic field? It is Tesla. What is the unit of distance? That is meter square. Unit of current is ampere. Again unit of length is your meter. Here sin theta and 4 pi are the constants. So we get finally meter cancel with this and we have Tm A minus 1. This is the unit of your mu naught. And what is this mu naught? Mu naught upon 4 pi is basically, its value come out to be mu naught upon 4 pi. If we bring 4 pi here, it comes out to be mu naught upon 4 pi is equal to 10 raised to the power minus 7 Tesla meter ampere minus 1. This is the unit and this. Now see, vector form of this same law. यहाँ मैग्नेटिक फील्ड, सपोज देयर इज अ मैग्नेटिक फील्ड dB इज अ वेक्टर क्वांटिटी, यू नो. इसका फील्ड वेक्टर, इसका भी एक यूनिट वेक्टर अगर हम लें, इट इज ऑब्वियसली मैग्नेटिक फील्ड इज प्रोड्यूस ओवर दिस स्पेस एंड यू हैव सीन द रूल्स. अकॉर्डिंग टू दैट इट विल बी इनसाइड द बोर्ड, इनसाइड बोर्ड की तरफ को इसकी डायरेक्शन होगी. नो अगेन देयर इज वन अनदर, दिस इज द वन वेक्टर, यूनिट वेक्टर. अगेन देयर इज अ पोजीशन वेक्टर दैट इज योर r and you have ideal, again a vector. So you have here, this is also a vector, though it is a scalar form. This ideal quantity is a vector also, and you have one more vector, that is your dB, and a unit vector which is producing it, that is your n, unit vector. Now how to find its vector form? For example, if you want to go for it in detail, let me write it. dB is a vector quantity over here, mu naught upon 4 pi I dl sin theta upon r square n. This is n is a unit vector. Now how to move further? See students, here dl is a current element and ideal is a vector quantity. ये पूरा ideal vector quantity है. Suppose अगर ये current element को हम यहाँ रखते हैं, if I keep my thumb like that, it will turn like that. अगर इसकी हम मैग्नेटिक लाइन ऑफ फोर्स देखें, इट इज अगेन मूविंग इनसाइड. तो इसका मतलब क्या हुआ? इसका मतलब हुआ कि आइडियल इनटू आर मींस अगर आइडियल वेक्टर इनटू पोजीशन वेक्टर को हम एक साथ अगर मल्टीप्लाई करते हैं तो व्हाट वी फाइंड, आइडियल इनटू आर शुड बी इक्वल टू यूनिट वेक्टर. द सेम थिंग हियर हैपनिंग. यहाँ भी मैग्नेटिक फील्ड इनसाइड है, यहाँ भी. नाउ व्हाट विल डू? Now we will do one thing, dB equal to mu naught upon 4 pi. In place of ideal, I will be write ideal sin theta upon r square. In place of unit vector n, we can write now vector divided by its magnitude. Unit vector आपने पढ़ा है स्टूडेंट्स कि हम किसी a unit vector की बात करते थे. What is that? Vector divided by its magnitude, or any you can say for that reason. अगर आप किसी वेक्टर की बात करें तो वेक्टर divided by its magnitude. Let's move further with this procedure. See it very carefully students. Here unit vector is vector divided by its magnitude. Now what will happen? Now this is very clear. Now dB is mu naught upon 4 pi I dl sin theta upon r. Now this vector is now equal to, that is I dl into divided by IDL R sin theta. Now students, ideal cancel with ideal, sin theta cancel with sin theta, and we are left dv equal to, because this is a vector form, and in magnitude of unit vector this is a scalar form. Now in the magnitude of ideal R. Now we'll get mu naught upon 4 pi I dl into R upon R cube. This is the vector form of your Biot Savarts law. Students, remember its vector form. It is of immense importance. जैसे कूलम्स लॉ में चार्ज स्केलर होता था, या बिल्कुल ठीक वैसे आइडियल यहाँ पे क्या है, वेक्टर है. ये बहुत बड़ा फर्क है कूलम्स लॉ में. कूलम्स लॉ पॉइंट चार्जेस के लिए होता था, यहाँ हमने वैसा ही कुछ स्थिति बनाई थी. इट इज एनालोगस टू कूलम्स लॉ कि क्या कोई छोटा सा पॉइंट करंट एलिमेंट क्या मैग्नेटिक फील्ड बना सकता है, तो यस, उसका नाम था आईडीएल. आईडीएल इज अ करंट एलिमेंट. लेट्स स्टार्ट विद द एप्लीकेशन ऑफ बायोट सैवर्ट्स लॉ. Application of Biot Savarts Law में number 1 application will study magnetic field due to infinitely long straight wire carrying current. Let us consider a wire AB carrying the current I. Now from the current element, जो कि सबसे छोटा element है, to generate a magnetic field. Current element से magnetic field हम calculate करेंगे point P पर. Center of conductor से, that is at a distance L. Now what is the magnetic field due to current carrying element? That is mu naught upon 4 pi I dl sin theta upon R square. Let it be your first equation. Mu naught upon 4 pi I dl sin theta upon R square. Let it be your first equation. Now students see, in right angle triangle POC में आप देखेंगे, in right angle triangle we can see now, इसमें हम देखेंगे sin phi. What is sin phi? Sine is perpendicular upon hypotenuse, so it will be equal to your A upon R. हमेशा एंगल के सामने वाला perpendicular होता है. It is also equal to cos theta. अगर आप थीटा से एंगल को थीटा मानेंगे, from this side it will be again base upon hypotenuse, so this will be A upon R. और अगर आप sin phi से चलेंगे, it will be A upon R. Let this equation be your second equation. This is your first equation, this is your second equation. Now we have to see tangent theta also. What will be tangent theta? Tangent theta here is, let me rub this. What is tangent? Tangent is perpendicular upon base. So tangent theta here will be L upon A. From here we can get A tangent theta, and for small element dl it will be A secant square theta. Let this be your equation third, that is A square theta d theta. Now just putting the values in your equation 1. dv here is mu naught upon 4 pi. In place of, here you will write, in place of dl you will write A secant square theta d theta, and in place of sin theta you will write cos theta, because we have seen sin theta is sin phi. In place of sin phi, sorry, here we will take it as sin phi, यहाँ पे phi angle था. In case of sin phi you will write here cos theta. And here in place of R you will now write here A upon cos theta, because this is the value of R. R की value हमारे पास आई थी A upon cos theta. Because we have A upon R हमारा cos theta था, वहाँ से we can find the value of R, which is A upon cos theta square. By solving dv we get here dv, here we are not taking a vector form, it is a magnitude form. So here the dv comes out to be, finally we have dv expression equal to mu naught upon 4 pi. Here it is A square, so one A will get cancel out, and we are left with I cos theta upon A into d theta. Of course, d theta will be there. So this is your equation number 5th. Now, magnetic field due to the whole conductor. Field due to entire conductor, due to whole conductor will be given by integrating the dV in the limits theta 1 to theta 2, that is minus theta 1. Here we will take minus theta 1 according to sign convention. It is going this side, that is minus theta 1 for the magnetic field, and it is up to theta 2. So we will have dV, that by integrating we have mu naught upon 4 pi I upon A, that is minus theta 1 to theta 2 cos theta d theta. And what is the integration of cos theta? That is your sin theta. Now we will get mu naught upon 4 pi I upon, let's do it here, mu naught upon 4 pi, it comes out to be, what is the integration of cos theta? Integration of cos theta is just sin theta, that is mu naught upon 4 pi I upon A. Now we are integrating it, we are getting upper limit minus lower limit, that is sin theta 2 minus sin theta 1, that comes out to be mu naught upon 4 pi I upon A, that is sin theta 1 plus sin theta 2. This is your final expression for magnetic field. But for a long conductor, if theta 1 is equal to theta 2 equal to pi by 2 for straight conductor, infinitesimally straight conductor, if theta 1 equal to theta 2 is equal to pi by 2, then value come out to be mu naught upon 4 pi I upon A, that is your sin pi by 2, that is sin 90 plus sin 90, that comes out to be mu naught upon 4 pi I upon A into 2, comes mu naught I, that is mu naught I 2 pi A, that is your magnetic field expression. Students, we finally obtain the expression of B equal to mu naught I 2 pi